So we'll look into various types of services that we use as layers. So layers can offer two different types of service to the layers above them. So one is connection oriented and other one is connection less service. So in this slide we will look at these two types and examine the differences between the connection oriented and then connection less services. Let's begin with connection oriented service. Connection oriented service is modeled after the telephone system. That was the initial that was the primitive or first network that has been built to talk to someone. You pick up the phone, dial the number and talk, and then hang up. That's how you do with your telephone, correct? What do you do to talk to your friend, a girlfriend, or your parents? You pick up the phone, dial the number, talk to them, and then hang up. So that's what you do. So similarly, to use a connection oriented network service, the service user first establishes a connection and uses the connection and then releases the connection. That's what that's what we call as a connection oriented service. It's basically inspired from the telephone system. The essential aspect of a connection is that it acts like a tube. The sender pushes bits of data in at one end and the receiver takes them out at the other end. In most cases the order is preserved so that the bits arrive in the order they were sent. In some cases, when a connection is established, the sender, receiver, and subnet that we have discussed in our previous slides, sender, receiver, and subnet conduct a negotiation about the parameters to be used, such as maximum message size, quality of service required, and other issues. So typically one side makes a proposal and the other side can accept it, so or reject it. It's like proposing a girl. So you can make your proposal, it's all up to her to whether accept it or reject it or make a counter proposal. So if she wants to be with you, she may propose, she may counter propose, she may give you some counter proposal. So a circuit is another name for a connection with associated resources such as a fixed bandwidth. This dates from telephone network in which a circuit was a path over copper wire that carried a phone conversation. Then we will look into a connection less service. What is a connection less service? In contrast to the connection oriented service, connectionless service is modeled after the postal system. How a postal system works: each message or letter, let's take it as a message is equivalent to letter in this example. Each message carries the full destination address and each one is routed through the intermediate nodes inside the system independent of all the subsequent messages. So there are different names for messages in different contexts. A packet is a message at the network layer. Basically, for us, a packet is it's a message at the network layer. When the intermediate nodes receive a message in full before sending it on to the next node, this is called as a store and forward switching. This is what we call as a store and a forward switching. The alternate the alternative way of doing, or the alternative to this is in which the onward transmission of a message at a node starts before it is completely received by the node, and is called cut through switching. So we'll have two types of switchings in connectionless service. One is store and forward switching, and cut it and through switching. That's a cut through switching, and then store and forward switching. Normally, when two messages are sent to the same destination, the first one sent will be the first one to arrive. The first one that you have sent is the first one to arrive. So however, it is possible that the first one sent can be delayed so that the second one arrives first. There is a possibility of that also. So now we have seen connection oriented and connection less services, both types. The layer can be either connection oriented or connection less service. So each kind of service further be characterized further be characterized by its reliability. Some services are reliable in the sense that they never lose data. Usually, a reliable service is implemented by having the receiver acknowledge the receipt of each message, so that the sender is sure that it's arrived. The acknowledgement process introduces overhead and delays, which are often worth it but are sometimes undesirable. So you can see a connection oriented and then connection less, whereas a connection oriented, it's a reliable message stream. It's a reliable. And in connection oriented, you can have an unreliable connection. That's example voice over IP. So these are the services which can be done through connection oriented and then connection less, and some of the examples that I have mentioned. A typical situation in which a reliable connection oriented service is appropriate is file transfer. A normal file transfer. A reliable connection oriented service is aptly fit with the file transfer. The owner of the file wants to be sure that all the bits arrive correctly and in the same order they were sent. So very few file transfer customers would prefer a service that occasionally scrambles or loses a few bits, even if it is much faster. So you have two options: either you choose a safe and correct way of sending all the data, or you choose the fastest way of sending and then some data missing or data scrambling. So either you choose one. If you go for the safest and then correct way of sending, then we will go for the reliable connection oriented service, or else you can go for the unreliable datagram. So now a reliable connection oriented service has two minor variations. What are those? The first one is message sequences and byte streams that you can see on the screen. It's exactly in front of your eyes. So message sequence and byte streams. In the former variant, in the message boundaries are preserved. When two 1024 byte messages are sent, they arrive as two distinct 1024 byte messages and never as one 2048 byte message. Whereas in the second case, in the byte streams, what happens is the connection is simply a stream of bytes with no message boundaries. So that is the reason when 2048 bytes arrive at the receiver, there is no way to tell if they were sent as one 2048 byte message or two separate 1024 byte messages, or 2048 1 byte message. It's not exactly clear. So that's why First one is a reliable message stream that exactly passes whatever the sender has sent, whereas the reliable byte stream, that we cannot say. Now, the next example, if the pages of a book are sent over a network to a photo typesetter as a separate message, it might be important to preserve the message boundaries. Whenever there is a requirement to preserve the message boundaries, it's better to go with the reliable message stream. On the other hand, to download a DVD movie, a byte stream from the server to the user's computer is all that is needed, because message boundaries within the movie are not relevant. Now, for some application, the delays, the transit delays introduced by acknowledgements are unacceptable. Basically, if you don't want to have a delay, you want to send it as fast as possible, because if you go with the reliable connection oriented reliable message stream or reliable byte stream service, you will have a delay in sending. So if that is the case, if you don't if the delays are unacceptable, then one such application is digitized voice traffic for voice over IP. So it's like talking on the phone. So voice over through internet protocol is the one such digitized. Basically, this is called as digitized voice over, digitized voice. So in this case, we don't want delay at all. We don't want any kind of delay at all. In this case, we can go for, so it is less disruptive for telephone users to hear a bit of noise on the line from time to time than to experience a delay waiting for acknowledgements. So when you are speaking on the phone, which one would you prefer? A slight delay is better, or a slight noise is better, or a long delay is better? Which is better for you? As a mobile phone speaker, I would prefer to have zero delay, and if there is a slight amount of noise, it's absolutely fine. So that's the reason in this case. Similarly, when transmitting a video conference, having a few pixels wrong is no problem, but having the image jerk with a delay as a flow stops and starts to correct errors is absolutely irritating. So that's why, based on the requirement, the service can be changed or can be used, can be customized. So then we can go for the unreliable. So unreliable meaning it's not acknowledged. That's the only difference. Unreliable doesn't mean it's completely unreliable. The only difference between the reliable connection oriented and the unreliable connection oriented is, the reliable connection oriented, it is acknowledged, and whereas an unreliable connection oriented is not acknowledged. So unreliable connectionless service is often called as a datagram. So here, this is what we are talking about. This is connectionless service. It's a connectionless service, datagram service. In analogy with the telegram service, which also does not return an acknowledgement to the sender despite its being unreliable. It is dominant form in most networks for reasons that will become clear later. So now, to the acknowledged datagram, also we can have the acknowledged datagram service can be provided for these applications too. It's like sending a registered letter and requesting a return receipt. That's what is called as acknowledged datagram. When the receipt comes back, the sender is absolutely sure that the letter was delivered to the intended party and not lost along the way. So text messaging on mobile phones is a best example for this. You just want to get that receipt saying that the message was sent successfully to the intended person. So now, still another service is the request reply service. In this service, the sender transmits a single datagram containing a request. the reply contains the answer. So request reply is commonly used to implement communication in the client server model. So what is client server model? Let us look into the client server model in forthcoming slides. So the client issues a request. Of course, the client issues a request whatever he wants, and the server responds to it. This is what we call request reply service. And or else basically the best example is a database query. The best example is database query. So a service is formally specified by a set of primitives or operation. Primitive is nothing but operation available to user processes to access the service. So these primitives tell the service to perform some action or a report on an action taken by a peer entity. So if the protocol stack is located in the operating system, as it often is, the primitives are normally system calls. So these calls cause a trap to kernel mode, so which then turns control of the machine over to the operating system to send the necessary packets. So the following are some of the operations that we do for each service. Basically, irrespective of the service, these are the some of the operations or primitives that we do. So the set of primitives available depend on the nature of the service being provided. So the primitives for connection oriented service are different from those of connection less service. So just we'll look into some examples. So one of that such primitive is listen. What listen does is, so block waiting for an incoming connection. And what connect will establish a connection with a waiting peer and accept an incoming connection from a peer and receive it, block waiting for an incoming message and send a message to the peer and disconnect, terminate a connection. Like that, from listening and then connecting, accepting, receiving, sending, and then disconnecting the connection. So this is how a service basically do the operation. These are the operations that will be normally available in a service.